Let's talk about adding and subtracting fractions. This will be one of the hardest things that we're going to try to do this year because there's so many different things that you have to be aware of. So if we take a number like 1/2 plus 1/2, okay, we're going to look at our denominators, and because they're the same, we know that we're counting in halves, okay? We're not worried about adding the denominators, all right? What you are going to be adding are your numerators. So if I have 1/2 plus 1/2, I have 2 halves. A way that you can look at this is if you take, and we're going to draw a cookie, just because it's kind of a circle looking thing, and we're going to divide it in half, okay? On this side, on this half, okay, we're going to have this first part of our addition equation, all right? And then we're going to look at this half for the second half of our equation. Well, if I have half a cookie, I'm sorry, if you have half a cookie and I give you half a cookie, you have the whole cookie. Well, anytime your numerator and denominator are the same, you have one whole, okay? Well, this works for any and all fractions. So what happens if we were to add 1/4 plus 1/4? Okay, so let's draw another model. We're going to make a circle. We're going to divide it into fours. Okay, so we have our first fourth right here, our second fourth right here. Well, if you think about it, we're still not going to do anything with our denominators because we're talking about our cookie being split into 4 pieces. So we know that we're counting in fourths. Now we add our numerators. 1 plus 1 is 2. Well, if you think about what this looks like in comparison to the top one, 1/4 and 1/4 equals 2/4. This fraction can be simplified by simply dividing your numerator and your denominator by the same number. In this case, we know that 2 can be divided by 2 and 4 can be divided by 2. And it's really easy to see here where you have 1/4 and 1/4, which takes up half of your cookie, that looks very similar to this one. Okay? So what happens if our denominators are not the same? All right? So what happens if we have 1/3 and we add 1/2? Okay? If we try to draw a circle doing this, you're talking about thirds and halves. They're not really the same, are they? No, they're not. So we have to find what is called a common denominator. I'll write this in real quick. And what happens is, by finding a common denominator, that puts us into something that we can add together. Like up here, we had fourths plus fourths. Here we had halves plus halves. When you're talking about thirds and halves, they don't really match up too well. So one of the things that we can do is we can write out our multiples for each thirds and halves, okay? So if you think about your multiples of 3 and your multiples of 2, okay? 2 times 1, let's try 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. Let's just start with that and we'll see where we end up. Now, can we compare this with the 2's? Absolutely. You're going to write your multiples. 2 times 1 equals 2. Okay, well, we don't have a match yet. 2 times 2 equals 4. I still don't see anything in here that matches up. So what about 2 times 3 equals 6? Oop, looky there. We have a match, all right? So what this says is that we can use 6 as our common denominator, all right? So now if we rewrite our problem and we change our denominator to 6 instead of thirds and halves, okay? Now, what times 3 equals 6? Well, 3 times 2 equals 6. So if we multiplied the denominator by 2 to get to 6, we do the same to the numerator. Well, 1 times 2 is 2. All right? Now, on the second half, we started in halves, we're ending in 6. What times 2 equals 6? Well, 2 times 3 equals 6. So we multiply the top and the bottom both by 3. 2 times 3 equals 6, so we know we're good there. 1 times 3 equals 3. Now we're looking at our model. We can recreate a model that's going to put us into sixth. Okay? And because we're talking about sixth, and I'm a horrible artist, let's try doing this with a bar model instead. Okay? So I'm going to break this into 1, 2, 3, 4, 5, 6 pieces. So I have 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. Okay, so 1, 2, 3, 4, 5. I have 6, 6. That gives me a whole. All right. So with our first one, we needed 2/6. So we're going to take these 2/6 and we're going to represent 2/6. Then we need 3/6 for the second one. So I'm going to come over and I'm going to encompass 3 of them. Well, 1, 2, I have 3/6. Now, if you look at your model, I have 1, 2, 3, 4, 5 out of my 6 pieces that are accounted for. Well, if you think about it, 3 plus 2 equals 5. And my denominator is still 6 because that's what we're counting and that's what we need to get a whole. So 2/6 plus 3/6 equals 5/6. Therefore, 1/3 plus 1/2 equals 5/6 because we did the conversions or the multiplication on our denominator and used it as well to our numerator.